These are all the lubrication and hydraulic pump starters, 440 volt, 3-phase machines. The board is live, buzz bars are live, no control supply on. We'll now enable the control supply. Two control transformers. Switch on the board supply. The solenoid transformers for the LTAC boards out on the mill, entry and exit LTAC boards. That's the supply to those boards. Bander. CIS 5. And finally the interlock relay switch. Right, that enables well, there we have the oil mist section. Oil mist trip relay at the bottom. Pinch roll roller side guides. Pinch roll rotate itself. Gear lubrication system. Gear common control section. Bearing temperature trip. This is the main drive motor bearing temperatures. The roll balance section, roll camber. Auxiliary hydraulic pumps, 1 to 6. Continue powering up in the regulating room. We need to switch on the alarm supply, which also provides supplies for some of these indicator lamps here. Right, we have some indication now. Here we have the mill auxiliaries board, the fume exhaust fan current indication. There's a starter. We have the thyristor room, cooling fans, the main motor cooling fans, screw down motor cooling fan, the air makeup tunnel fans, and the oil cellar inlet and outlet fans. The alarm panel is quite simple. First up, flashing alarm, which you can accept to read. The master is indicating a problem. Push the button and we can see control supply we have a problem with, which we've not yet switched on the DC excitation. We're going to put the DC excitation on the flat back. This is the stands, the main brake control, sequencing for those. Close the offload isolator. Close the interlock isolator, which then enable us to bring in number 10 switch, and the DC excitation will appear. That's it. The X is pulled in. We have excitation. More indication has now appeared in this cabinet. We have more control supplies. Hopefully this master control supply, let's accept and reset that. Okay, the master alarm has disappeared. Right. We now need to switch on the main drive motor fields. Supply from this ancillaries board at the end of the room. Problem with this one. Right, okay. Unlock the lid. The carrier tends to spring out. That's it. Put it back up. Right, we'll close now, hopefully. That's it. Gauges, tensiometers, load cells, a variety of equipment is supplied from this board. This is the room air conditioning system, very crucial in maintaining stable conditions, ensuring that the equipment is adequately cooled in warm weather conditions. Now the fields which we've just put on should drop down to economy value, which I have. If you look at this supervisory board here, you can see the fields have dropped down to a low economy level because we have no cooling fans selected yet. Supervisory panel for all the stands and the reel. Don't want to put the fans on yet until I've been down into the basement. No, I'll go into the basement afterwards. This is the exit LTAC panel where we have roll changing equipment and also roll changing equipment and also the solenoid control for all the delivery equipment. Move through to the screw down board F, fed from the 250 MVA board, which is on the compound on the right. We've got to close these 5 breakers to put the AC supply onto the screws. Screws 2. Screws 3. Screws 4. See the kick and current as we close up. Screws 5, power drive being the Sigma. There we are, they're all closed. Here we have the entry LTAC board, again powered from the idle lube room. This is the screenshot for a moment. Pushing roll limit we have problems with. We are brigging that temporarily to load a coil. We need to load a coil to allow the pushing roll to operate and needs attention. This is the 33 kV supervisory panel, where any trips from the converters which are going to knock out the 33 kV breaker originate from. That is the auxiliary transformer which feeds all converters, and where the reference voltages for the firing circuits are derived. And then you have each stand, 2 transformers per stand, one for the top converter and one for the bottom converter, all the way through to the reel. Of course we have 33 kV coming into this box here. The outgoing side, the tails drop down straight onto the bus bars on the converters immediately below. This is the 33 kV offload isolator substation. You can see the motorised control units for feeder 1 at the far end now, which is going to operate the mechanism to close up the 33 kV. But at the moment the 33 breakers open, so I can close this offload isolator from the local controllers here. This is the control panel which allows us to close that offload isolator to feeder 1. I have the interlock key. I can see that there are no bolts on the bus bars, so the 33 kV breaker for feeder 1 is not closed at the substation. So I can operate the key. I can now close the offload isolator. Okay, we heard that operate. I remove the key to prevent unauthorised operation. We can go back upstairs. The auxiliary DPC equipment is live. This remote I/O for the screws is active. We're searching for datums on 2 stands. Datum's not set. We have the old Mark 5 Unistat equipment on stand 1 screws, stand 2 screws, wired logic units. We have a new Sigma on screws 3, control only, screws 4, control only, and screws 5 we also have a power sigma, a dual power sigma to drive the front and back screw independently. This is the static status of this stand 5 equipment. The IO LEDs indicating whatever, and the Sigma IO board there also indicating its status via the array of LEDs. The load cells are powered up. See the mains on light. If we have a problem, the mains will usually drop out. Stand 4 still retains its old original 1974 equipment. Tensiometer equipment is all live and healthy, and we have the 3 sets there. There we have stand 3, stand 4 and 5 to reel. 5 to reel, single roll tensiometer, has new electronics installed, and we can see very little differential on those meters of they're reading somewhere near. I'll now start up the cooling fans. Two out of 3 in this section. Two here in this section. 2 in this section. Heard the contactor come in there, and the main drive motor fields now have gone up to their maximum value, full field values. Yeah. Okay. Right. All fields healthy. Carry on, screw down ventilation fan, start that. We don't need the air makeup, we don't need the oil seller. Now this is the big monster to remove the oil mist from the system. We're going to close up this. You see the current zooms around there, you'll hear it start. That's a fume extract fan. Hangs there for a while. Hopefully that's it, belts are slipping, pull back to its normal running value. So that's running. Forgot to mention these rotary switches, test switches on this DC flatback panel, which do a fault finding. We have no earths on the DC supply, lamps are balanced in intensity. We can now, as long as lubrication has been turned on, which I assume it has by Glyn, close up the screw down DC breakers. 1, 2, 3, 4. Now stand 5 needs a reset on the Sigma to the reset button to clear this alarm. Input's healthy as per the other drives. We can now close that DC circuit breaker. Okay. Mill master control is off. All the breakers out on the mill are probably turned to the reset position. We've closed up the feeder isolator downstairs using the interlock key, so the red lamp illuminated there. We've still got no 33 kV showing until I close feeder breaker number 1 D66 controller. Before I do that, I'll check with Glyn. This is the mill parameter screen. Gauges are not operating, sources have been removed, so there will be gauge alarms. We've got a little bit of a problem there. I've rebooted the computer several times, and you can see we've got 0 speed reference, 0 tension references, etc. Which means that we can't thread the mill because we've got no speed references. We could inch the mill, set datums, then try to send the setup out and get something sensible if we want to thread the mill, but we mustn't thread at the moment, it'll lock itself up. Again, we've got no 0 gauge references. There's a width of 1387, but 0 gauge references. You see the screw positions indicated there. Shape display. This is the histogram display for the operator. Nothing showing there. A repeat of the shape display. We see on the top of the mill the lamps indicating that the screws are in a fully raised position. Those lamps, screws are in a fully raised position. The backups are sitting on jugs off the work rolls. We also see the warning light there to say there is a problem in the cellar, hydraulic cellar. At the back of the reel there is on the front of the reel there is a mandrel expanded lamp which is not illuminated yet. There it is, to say that the mandrel is not yet expanded on the reel. Yeah. So we've got to get the work rolls into an operating position. There's an array of lamps on the top of the mill indicating the status of safety gates. Just about to see them there. That's right. Okay. The indication on the desk tells me that there's a problem. We haven't got system healthy. So I need to check the main computer. We have the main computer. Standby computer. The main computer is not running. It's where the system disk drive is located in the switch extension unit. So I'll have to reboot the computer using the console. If I break, there's a message. Let's just view that. There's a message indicated on there as to the status of why the equipment failed. If I halt the machine, brake, halt. We must be online, of course. We must be online. We must be on caps lock for communication to be satisfactory between this unit and the computer. The keys, the bootstrap keys, or the key number for the system disk is 15F0. This dual platter drive. Logging is on the top platter, system on the bottom platter. Top platter 10F0, bottom platter 15F0. So I'll boot from 15F0. Because I haven't reset the computer, the keys 15F0 will be retained in memory. So all I need to do to kick the thing off is to type L2, return. The equipment will now try to boot. You can see the activity there on this drive. It'll come back asking me for the time, enter the time and date. If I put in the time, TIME space 90. I'll come back asking me for the date. What's the date? Date is Wednesday the 17th of September 2003. Right, going through to boot up sequence now. Okay. These are the normal messages which appear. Warm, type in warm now, W-A-R-M, a warm start. Let's type in warm now. Just about got it in. I'll show you what I'm doing. There's a lot of terminals not connected. Right. Conrad has got to start up Conrad control software. Different phases which it'll go through. While this is printing out, I'll go through into the other room. This is the engineer's VDU in the computer room. Session started, flag is indicated there. I need to log in as EFDA on that screen, but there's a problem with that at the moment. I'll leave that. The entry VDU and the inspector's VDU should have initialized and powered up. The operator's VDU is sitting static, waiting to be refreshed. The delay logger will burst into life at some stage and the screen will become refreshed. That's the production logger, which needs paper in. That's the delay logger. If any logger fails, the messages are diverted to the other printer, but they should really all be in operation. Mill stops for more than 2 minutes. A delay message will be printed and the operator prompted to enter something on the screen by the keyboard. The displays on the VDU can be altered. via this thumb wheel. If I enter, there we are, sorry I won't enter that in any of the printer. This will refresh, so we'll come back to the main puppet operator's display, hopefully. Right. Okay. I then need to Conrad and Elthie, Conrad Elthie, enter reason for delay. Okay. What we need to do now is to select the parameters screen, which we have done. Start data input. Start data input. I might move to previous field to get the cursor into the accept all data before system will become healthy. Just have to reset all the data. Type yes, enter, enter. System becomes healthy. We're now in operating state.